vertical asymptotes and wholes of rational functions. So our objective here, we want to identify vertical asymptotes and wholes in the graphs of rational functions. And we'll take a look at that with our graphing calculators. Let's remind ourselves, we know what a rational function is. It is the quotient of two polynomial functions. Because we're dealing with a quotient, we have a denominator, and as we know, our denominator cannot be 0. The domain of a rational function is the set of all real numbers except the x values that make the denominator 0. Why? Because division by 0 is undefined. So what is an asymptote? That funny word. An asymptote is simply a line that guides the graph of a function but is not part of it. So if this is my function, it's this curve here. You can see that this line here is helping to guide the curve as the x values increase to positive infinity. It's not part of the graph, it's not on the graph unless you were to put it on the graph, but it is guiding what the curve is doing. Asymptotes can be vertical lines, horizontal lines, or slant lines that are also called oblique. This line is obviously a slanted line. It's not vertical or horizontal. So this asymptote would be a slant asymptote. Again, they also use the word oblique in place of slant. So a slant or an oblique asymptote. Well, we're going to focus on vertical asymptotes. So what does that mean? A vertical asymptote is a vertical line. And the equation of a vertical line is x equals a number. So it's a vertical line that guides the graph of a function, but is not a part of it. Okay, a vertical asymptote can never be crossed by the graph because it occurs at an x value that is not in the domain. Okay, so the graph can't cross it. And a function may have more than one vertical asymptotes. You can have an unlimited number of vertical asymptotes depending upon the rational function. So here are some examples of vertical asymptotes. Notice there are all these vertical lines, x equals a in these cases, and what functions could do. In this case, the function as x is approaching a from the right, the plus sign means approaching from the right, the graph is going up to positive infinity. Here, as x's approach a from the left, the minus sign means from the left, the graph is going to positive infinity as well. Similarly, with this vertical asymptote, as your x's are approaching a from the right, okay, and that's what the positive means. In this case, the function's value is going to negative infinity. And again, same thing here. Now we're approaching the vertical asymptote from the right, and this graph's value is going down to negative infinity as well. Okay, let's do a couple of examples and take a look. I think I've got a couple of examples lined up for us. Finding vertical asymptotes or wholes. So we're going to pull in the wholes piece of this. Finding vertical asymptotes. As necessary, we need to completely factor both the numerator and the denominator. Okay. A variable factor that is only in the denominator is a vertical asymptote shaping the graph. A variable factor that is in both the numerator and the denominator will be a whole in the graph. In both cases, they are not part of the domain because they are zeros in the denominator. Let's take a look. Algebraically find the vertical asymptotes, if any, and the wholes. So I should have here and wholes. Sorry about that. Of each rational function. Use your graphing device to check your answer. So here's my rational function, x over x squared minus 9. The numerator is totally factored. The denominator is a difference of squares. It can be factored as x plus, it can't be, it can be, it is factored as x plus 3 times x minus 3. Now we're totally factored. Okay, so we know we cannot have a 0 in the denominator. So x equals 3 and x equals negative 3 are not in the domain. Are not in the domain. They result in a 0 denominator, and the function cannot return a value when you have a 0 denominator. So now let's take a look at the two factors. Okay, is this factor in the numerator? The answer is no. There is no x plus 3 in the numerator. Is this factor in the numerator? The answer is no. X minus 3 is not in the numerator. So I'll write neither as opposed to both. Neither factor, x plus 3 or x minus 3, is in the numerator. So x equals 3 and x equals negative 3 are both vertical asymptotes. Okay? So completely factor. Check out your denominator. Well, we have a 3 and a negative 3 that are not in the domain. Okay, are they vertical asymptotes or wholes? Well, neither of these factors is in the numerator, so they are both vertical asymptotes. Let's take a look. Make sure I can see my screen with you. I may have already done this. No, maybe I didn't do this one. Nope. Here, let's set this up. Use my fraction bar for a division, for a rational. My numerator, I have just the x, and the denominator, I have x squared minus 9. And I'll make sure I'm in the standard window, so I'll go to my Zoom 6, and you can see here. There we go. That's my graph of that rational function, and you can see that here at 3. You can see there's a vertical line that is shaping the graph. It's not there, but it's shaping it. And you can see here at negative 3, there's a vertical line that is shaping the ends of the graph there. If you were to go to value, second calc value, and you were to put in negative 3, for example, the calculator says, I can't give you a y. Cannot return a y value because you are trying to divide by 0, and that does not exist. I can't do that. So that's why negative 3 is not in the domain. The function is unable to return a value. Okay, let's do a second example. And this time, there we go. This time we'll call our rational function g of x, and it's x plus 3 divided by x squared minus 9. As necessary, completely factor. Well, the numerator is already factored. The denominator is a difference of squares. It can be factored as x plus 3 times x minus 3. So again, what do we know? We know that negative 3 and positive 3, x equals positive 3 and x equals negative 3 are not in our domain. Are they vertical asymptotes or wholes? Okay, but they're not in the domain. Does the graph have them as vertical asymptotes, or is there a hole in the graph? Well, let's see here. X minus 3, okay, is not also in the numerator. It's not also a factor in the numerator. I have x minus 3 in the denominator. I don't have an x minus 3 in the numerator. This tells me that x equals 3 is and I'll abbreviate with a VA, is a vertical asymptote. Okay, it's not in the domain. It's a vertical asymptote if it's not in the numerator, if that factor is not in the numerator. Let's notice that x plus 3 is in the numerator. So the factor x plus 3 is in the numerator. Okay, so I have an x plus 3 in my denominator and an x plus 3 in my numerator. So this tells me that the x equals negative 3, if this is a factor, then negative 3 is the 0, is a hole in the graph. Okay, let's take a look at that. We're going to have to do some zooming in to see it, but it is there. You just got to be kind of patient with some zooming in. So I'll go back to y equals. My numerator in this case is x plus 3. I think my denominator is still x squared minus 9, and let's press graph. So there it is. Okay, so now you can see the vertical asymptote at x equals 3. Here's x equals 3 here, and here's the vertical asymptote that is helping to shape the graph. But you really can't see the hole at negative 3. We know there's a hole at negative 3, but we can't see it. If we zoom in really tight, we can see it. Okay, so I'm going to go into my window, and I'm going to go just to the left, negative 3.01, which is just to the left of negative 3. And I'm going to go just to the right to negative 2.99. So I've surrounded negative 3, and I'm really in there tight. Okay, let's see if that will help me. I think I need to zoom in on my y a bit tighter too. I'll go from negative 1 to 1 on my y-axis. Let's see if that helps me. There's the graph. And blip, there's the hole right there. So I zoomed in so tight that you can see the hole right here in the graph. Okay, there's your hole at x equals negative 3. I had to zoom in super tight to see it. Let's go back to the standard window and draw that graph. Again, it's hard. You can't see the hole very well here at negative 3. It's right in there. You can easily see the vertical asymptote. But we can go to calc a value, and I can put in negative 3, and we know it's not going to give me an output, but here's the check. Sorry, Coleman, you can't put negative 3 into this function. It won't return a value because it results in a 0 denominator. Okay, next example. How about this one? H of x is a rational function, x plus 3 over x squared plus 9. Okay, it turns out I cannot, neither the numerator nor the denominator is factorable. Okay, so I can't factor this. There's no such thing as a sum of squares. This is already factored as x plus 3. Now, if we look at the denominator, when is it 0? We notice that we're trying to square a number and get a negative, and I cannot do this in the real number system. Okay, this can't happen in the real number system. So it's not factorable. There's no possible 0 in the denominator, so I have no vertical asymptotes or holes in this case. Okay, there's no real number that affects the domain or that sets the domain equal to 0. Okay, I'll do one more look at this. I think I've got an example with some more stuff going on. All right, let's remind ourselves, just a second here. Okay, zeros in the denominator, real number zeros in the denominator are either vertical asymptotes or holes in the graph. And as I mentioned, you can have a rational function can have any number of vertical asymptotes or holes. Let's take a look at one more example that requires a bit more factoring. Okay, so let's factor this out. In the numerator, I can factor out a 5. And I have x squared plus 5x plus 6. In the denominator, I have a quadratic. Turns out this quadratic is factorable. It is x plus 2 times x plus 1. Now, is this quadratic factorable? And yes, it is. I made the problem after all. X squared plus 5x plus 6 factors as x plus 3 times x plus 2. And again, I'll rewrite this one. It's already been factored. X plus 2 times x plus 1. So what do I know? Negative 2 and negative 1 are not in the domain. Are they vertical asymptotes or wholes? Well, x, I think it's x plus 1, right. Okay, x plus 1 is not also a factor in the numerator. Okay, there is no x plus 1 in the numerator. That tells me that x equals negative 1 is a vertical asymptote. Okay, now let's check out this negative 2. Okay, x plus 2 is also a factor in the numerator. X plus 2, x plus 2. This tells me that x equals negative 2 is a whole. So that one kind of put it all together, but I had to do some factoring first to get fully factored so that I could see my denominator of zeros, and I could see where I have factors in both the numerator and the denominator.